The engineering behind a modern refinery is truly a marvel. Miles of piping, massive vessels, and intricate systems all work together with unbelievable precision. But as any engineer will tell you, the system is only as strong as its weakest link. In one dramatic case, that weak link was surprisingly simple. It was the placement of a single anchor on a 10-inch pump discharge line. So this line was designed to transport high temperature materials away from a massive pump. But when it was actually installed, that anchor was placed significantly closer to the pump than the design had specified. See, the engineers who designed this system had used sophisticated computer models. So these models or stress models are absolutely essential in pipeline design. They simulate how the system will react to real world conditions, and one of the most critical factors is thermal expansion. When materials are heated, they expand. So when the pump heated up and the liquid inside it got hot, that 10-inch pipe was designed to grow slightly longer. The stress models had assumed a certain amount of flexibility. They had calculated exactly where and how much piping would move to absorb that thermal expansion. But with the anchor moved so much closer to the pump that flexibility was simply gone. The pipe had nowhere to grow. This meant all the forces from that expansion, all that thermal load was now being transferred directly into the pump nozzle itself. And the pump, of course, was never designed to take that kind of stress. It was a pressure vessel built to withstand internal pressure, not external forces. For several months, it was like someone was constantly trying to twist and bend the pump's most critical point. The symptoms were not immediate, but they were devastating. Within months, maintenance teams began to observe persistent alignment issues with the pump. Then the real damage was discovered. Fatigue cracks had developed right at the nozzle well. So this pump, the heart of the operation, was slowly being destroyed from the inside out. There were no other option. The unit had to be taken offline for an unplanned shutdown. The financial impact was massive, running into the millions of dollars in lost production and repair cost. The irony was that the piping itself, the 10-inch line, remained perfectly sound. It was the equipment which was connected is failed. So the symptoms were not immediate, but they were devastating. Within months, maintenance teams began to observe persistent alignment issues with the pump. Then the real damage was discovered. Fatigue cracks had developed right at the nozzle well. So this pump, the heart of the operation, was slowly being destroyed from inside out. There was no other option. The unit had to be taken offline for an unplanned shutdown. The financial impact was massive, running into the millions of dollars in lost production and repair cost. So, it was the equipment which was connected to the 10-inch pipeline failed. In the end, the root cause analysis was incredibly clear. It was not a problem with the material or the weld or the operator. The failure was caused by improper anchor location. A seemingly small installation error had reduced the system's flexibility and redirected a massive thermal load into a piece of equipment that was never designed to handle it. This case is a stark reminder. In a complex engineering system, close enough is never good enough. The design specifications are there for a reason, and even the smallest deviation can have massive consequences. When it comes to managing thermal loads, precision is everything. Thank you for watching. For more on the engineering challenges that shape our world, be sure to subscribe Piping Design Simplified.